Hey guys, I thought we could do a few more problems for simplifying and solving together and just kind of see how this goes. Sometimes these get a little bit messy, as I'm sure you can imagine. And the simplifying ones, just remember that you can multiply underneath the radical. You can't add and subtract. I'm going to go ahead and just kind of fly through a couple of these here, and hopefully we'll make it through without too much craziness. The -5 root 5 times the -2 root 10b looks like it's going to leave us with a plus 10. And what's that going to be? Root 50. The b. And we can simplify that a little bit more. The root 15 is not going to simplify, of course. And this is going to be, 50 is going to be the square root of 25 times the square root of 2. So we're going to have a times 5 and a root 2v on the inside. And then this is probably going to be as far as you can take a problem like this. Unless you have a square root that is the same value underneath, you're not going to be able to actually do any addition or subtraction. Okay, so something like that is kind of how that one rolls out. I'm going to go ahead and bring us down to this idea of a complex conjugate, and this one does get a little bit messy, and we probably will go over one like this in class as well. But I do want to give you an opportunity to see how to work with the situation that is going to result in trying to get rid of square roots and being successful in some places and not in others. So the way we're going to handle this is kind of similar to, and I'm just going to make a little reminder to you guys over here on the side, that something like x plus 2 times x minus 2 creates two binomials, creates a multiplication situation where the inside term, when you distribute, and the outside term cancel. So your result is difference of squares here, and you have no middle term. Well, we're going to kind of shoot for that same idea as we are working through this particular problem. And what we're going to do is we're going to multiply both the top and the bottom by the same binomial, except for instead of a minus sign, we're going to put a plus sign in there. And so we have plus 3 root 3a cubed, and we're going to multiply by that same thing on the bottom. Plus 3 root 3a cubed. And there's some simplifying that we could do first. That certainly is a possibility. I'm just going to go ahead and multiply these out. And of course, this is going to require some distributive property, and it's going to get a little long and crazy here. So I'm going to get rid of this little reminder of difference of squares, and we'll see how we do here. So first I'm going to multiply the 2 times everything in this next. So 6, 3a cubed, and then I'm going to multiply the positive 2 root 5a to the 4th. So what's that going to be? Let's see. So we're looking at 2 and root 15a to the 6th. Have to do some simplifying there. And last but not least, the 2 times the 3 is going to be a 6. And then underneath our square root, it looks like we're going to have 15a to the 7th. Wow, and that's a lot of terms that still can be simplified. The key for this problem is really going to be what happens on the bottom, okay, as we're about to start here. And we're going to be multiplying root 3a squared times itself. So that is just going to be a 3a squared when we're finished multiplying those. The inside and the outside terms are going to cancel. So I'm not going to write those down, but I would want to remind you that we would be multiplying this first term times this last term and multiplying here. And because those are similar values, just one is positive and one is negative, those will cancel. So the last thing I'm going to grab here is the minus, and 3 times 3 is 9, and root 3a cubed times itself is just going to be 3a cubed. So you can see right there that the square root has become no longer a part of your denominator. All right, so we can keep simplifying a little bit here. So let's simplify in the numerator with this term. This is going to be an a and root 3. And it looks like it's going to be plus 6a and root 3a. That was the a squared came out of there. Plus, let's see, 2a cubed. That's the square root of a to the 6. And the root 15 is going to stay. And it looks like 6a cubed. And the 15 and 1a value is going to stay there as well. Okay, and then on the bottom, what do we have? We have a divided by 3a squared minus 27a cubed. And if there are no other square roots that have matching values, then we cannot add or subtract anything else. So that is going to be, that's it right there. Those problems are crazy. It's the conjugate, called multiplying by the conjugate. So here's the crazy word that we're looking for when we use that process of multiplying in order to eliminate that square root in the denominator. All right, whew. Let's see how much time we have. I think we can move on to a little solving. And not sure which one. Should we just try? I mean, all of these are good to try. For example, on number 9, I think what I would do on number 9 is subtract 2 from both sides first. So again, this is kind of goes back to what we were talking about in class, where you need to isolate the square root, and you would have is equal to 10, and then we can square both sides. So we get 9x plus 10 is equal to 100, and subtract. And what else do we have left there? Subtract the 10 from both sides. Divide by 9. Okay, something like that to make sure something like that works out. Another one we could try would be something like question number 21 here. And again, we're going to isolate, this time we're isolating the expression that is being raised to the 5/6. So let's start that one right here. B minus 9 raised to the 5/6. And again, one of the strategies we want to use every time is to isolate this value that has the exponent. So I'm going to add 7 to both sides, and also I'm going to divide by a -1. So right now we have that -1 still attached as we add 7 here. Make this a -32. And then my b, as I divide by a -1, I get a +32. And now I'm going to raise both sides to the 6/5. So I'm going to raise this to 6/5. I get b minus 9 is equal to the 5th root of 32 to the 6th. Well, it's handy to know some of your roots, cube roots, 4th roots, 5th roots. The 5th root of 32 is actually 2 to the 6, which is going to be 64. And then when we add 9 to both sides, we get v is equal to 73. So working through a process like this, sometimes you have to change rational exponents back to radicals to keep going. Again, this is going to be something you could do in your calculator if you weren't sure about the 5th root of 32 being 2, and then again raising 2 to the 6th power. So that is a possibility as well, and I think as I look through there, we're pretty much set. Okay. There also are going to be a lot of problems when you are working through solving that require you to use the quadratic formula on ax squared plus bx plus c equals 0. Please don't forget that I'd like you to first try to factor if this is involved in your solving, and then use the quadratic formula if the factoring doesn't come to light for you very quickly. And then also, please remember that we're always checking our solutions. So once you are solving, and if you've squared both sides of an equation, you want to check your solutions and make sure that they work back in your original equation, guys. Okay, we will do more of these in class, and feel free to let me know the ones you want to work on. Hopefully that little example kind of gets you going again. All right.